Hello, everybody. I think all are seriously preparing for Telangana state eligibility test. Just to help you, I'm doing the video on quantum mechanics. So, this is the part 1 video related to quantum mechanics. So, in my this part 1 video, we are discussing about the some formulas and some fundamental basics related to this particular unit. So now here, classical physics, it explains about macroscopic objects, means the large objects whose velocity, momentum, etc. These properties can easily be predicted. But if we come for atomic, subatomic levels, the laws of this classical physics does not help us. In order to know about the atomic, subatomic particles, molecules, electromagnetic spectrum, etc., quantum mechanics we use, right? Or quantum physics explains about the atoms, molecules, subatomic particles, electromagnetic spectrum. This quantum mechanics or quantum physics generally explains about the principles of wave particle duality, quantization of energy, uncertainty principle. Okay. So now here just these videos are information at glance. So now quantum mechanics started with the Planck's radical assumption about atomic oscillators. An oscillator cannot have any energy. Okay, it doesn't have any energy, but only energies are given by E equal to h nu, where n is the integer, h is the Planck's constant, nu is the frequency of radiation. Now, oscillator do not radiate energy continuously. Energy is quantized. Delta E is equal to h nu. Now, the next topic that is about photoelectric effect. Now, photoelectric effect means I think you all are familiar with photoelectric effect, right? If this is particular metal and these are the electrons in the metal, then when light is incident on the metal, then electrons are emitted from the metal. So this process of emission of electrons from the metals, we call it as photoelectric effect. So photo means here photons are incident on the metal. Due to that, electrons which are responsible for the current flow are emitted. So only we call it as photoelectric effect, and this hypothesis is given by Einstein. So according to the Einstein's hypothesis, the photoelectric effect that light traveling through space behaves not like a wave at all, but like particle called photon. So Einstein's theory says that the light not only behaves like a wave, but also behaves like a photon, a particle we call photon. So Einstein's photoelectric equation is h nu equal to E naught plus kinetic energy K maximum, where h nu is the energy of photon, E naught causes the electrons to pass through the metal surface we call work function, and h nu minus E naught is imparted to the electron in form of kinetic energy. Now next, let us move to Compton effect. So here Compton effect means, now here First, a general explanation I will give related to the Compton effect. Now here, one electron, a free or a loosely bounded electron is present here. Now, the high energy photons. Here, high energy photons means we can assume as X-rays or gamma rays, right? When incident on this particular electron, so the momentum as well as energy are transferred to this electron. Now, this electron moves in one direction that we call as recoil electron, and the photon moves in other direction, we call it as scattered photon. Now, the energy of photon decreases and the energy of recoil electron increases, right? Now, when light photon is scattered by a gas or liquid or a solid, a major part of scattered light has same wavelength as that of the incident light. But there is also a part of scattered light with a change in certain wavelength. Now that change in wavelength we write as lambda dash minus lambda. Delta lambda is equal to, and that is written as h by m naught c 1 minus cos pi, that is equal to the value of h by m naught c is 0.0242 into 1 minus cos pi angstrom units, right? Here the lambda dash is wavelength of a scattered photon. Okay, lambda dash is the wavelength of a scattered photon. Lambda is the initial wavelength of incident photon. H is Planck's constant, whose value is 6.626 into 10 to the power of minus 34 joule second. M naught is the rest mass of electron, which is 9.11 into 10 to the power of minus 31 kg. C is the speed of light, 3 into 10 to the power of 8 meters per second. And pi is the scattered angle of the photon. Right? Now, next, let us move towards this wave particle duality. So, wave particle duality means here the light has a dual nature. One is the particle nature as well as a wave nature. Now, de Broglie says that every moving particle is associated with a wavelength or a wave, is associated with a wave. Now, the wavelength of such wave, he gave a mathematical formula for the wavelength of such wave associated with a moving particle, that is lambda is equal to h by p, where h as usual Planck's constant with the value of 6.62 into 10 to the power of minus 34 joule second. P is the momentum. Momentum means mass into velocity. So de Broglie wavelength lambda equal to h by p, that is equal to h by mv. Now, let us write this particular de Broglie wavelength in different terms. First, let us write in the terms of kinetic energy. Now here, lambda is equal to h by under root 2m ek. Right? Now next, let us write in terms of potential difference. Here, if V is the potential difference, Q is the charge of the electron, then or a particle, h by charged particle, q is the charge of charged particle, then h by under root 2m qv. And in terms of temperature, we write the same equation as h by under root 2m kt, where m is the mass of the particle, k is the Boltzmann constant. So the de Broglie wavelength in terms of kinetic energy, h by under root 2m ek, in terms of potential energy, h by under root 2m qv, in terms of temperature, h by under root 2m kt. Right? Now similarly, let us write the de Broglie wavelength of helium atom. That is equal to h by under root 3. Lambda for helium is h by under root 3m kT. Right? So now remember these particular formulas, practice the formulas perfectly. In many papers, he asked the formulas. Okay. De Broglie wavelength of electron accelerated through high potential difference. Let us assume that as V volts. That is written as h by under root 2 m naught EV into 1 plus EV by 2 m naught C square. As usual, the terms have their own meanings. C, velocity of light, m naught rest mass, E, charged particles charge, V, the potential difference, H, the Planck's constant. Right? Now next, let us talk about Heisenberg uncertainty principle. So the uncertainty principle says that it is impossible to determine position, and if we take the momentum, position as well as momentum simultaneously at one particular space. Now, in this space, for example, if in a well, if we throw anything such as a coin or any other thing, now if you concentrate in determining the position of that particular coin in that deep well containing the water, you cannot determine its velocity or momentum. And if you concentrate on determining the velocity or momentum of the coin, then you cannot determine the exact position of that coin. That what the Heisenberg uncertainty principle says. It is impossible to determine the position, uncertainties in position and momentum simultaneously. If delta x is the uncertainty in determining the position, and if delta p is uncertainty in determining the momentum, then delta x delta p is greater than or equal to h cut, where the value of h cut is h by 2 pi. Now next, similarly, let us apply the Heisenberg uncertainty principle in determining the energy and time. If delta is the uncertainty in determining the energy of the system, if delta t is the uncertainty in determining the time, then delta E into delta t is greater than or equal to h cut. Similarly, the uncertainty in determining the angular momentum and angle is written as delta j delta theta greater than or equal to h cut. Now, if we want the exact statement of Heisenberg uncertainty principle, then the exact statement says that the product of uncertainties in determining the position and momentum can never be smaller than the h cut by 2. Can never be smaller than the h cut by 2. So, we can rewrite the equations as delta x delta p greater than or equal to h cut by 2, delta e delta t greater than or equal to h cut by 2, delta j delta theta greater than or equal to h cut by 2. Now next, let us go for Schrodinger time independent wave equation, time dependent wave equation. You remember this many times in set exam he asked. In multiple choice, he will give the formulas. You have to identify the exact formula and you have to answer it. Okay. So now, before saying the formulas, a general view about the Schrodinger wave mechanics, let us discuss. The Schrodinger wave mechanics describes the behavior of the quantum particles. It explains or describes the behavior of quantum particles such as electrons, etc. It determines the particle's wave function, right? It determines the particle's wave function. Here, wave function, we are talking about wave function means this wave function contains the information related to the position as well as the energy, right? Position as well as the energy. Now, next, here we are talking about the wave function means Even we are talking about the wave function which changes over the time or when subjected to the external forces. Okay. Now here, this particular Schrodinger wave mechanics describes mainly about the quantum state and wave function. Here wave function means we can also say that it represent the probability amplitude of finding a particle at a certain point. What does the wave function represents? It represents the probability amplitude of finding the particles at a certain point in a space. Okay. Now next here, Schrodinger wave mechanics, we talk in two terms. One Schrodinger time independent wave equation, other Schrodinger time dependent wave equation. So Schrodinger time independent wave equation means, here first let us discuss about the formula. The formula is delta square psi plus 2m by h cut square E minus V into psi is equal to 0, where psi is the wave function, V the potential, E the energy, m the mass, h cut is equal to h by 2 pi. And del is the operator dou by dou x plus I dou by dou x plus j dou by dou y plus k dou by dou z. Del is the operator. Right? Now here we got del square means dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Now then, what does this time independent wave equation tells us? Okay, the time independent wave equation is nothing but the extension or the explanation, further explanation of time dependent wave equation only. Right? Now, it applies, this time independent wave equation applies to the systems with constant potential energy, right? Constant potential energy. It describes the stationary states where wave function probability distribution does not change over the time, right? So it explains about the constant potential energy of the systems, describes the stationary states where wave function probability distribution does not change over the time, right? And also it finds the specific wave functions and energies of the system where potential energy does not change with the time, right? It finds specific wave functions and energies of the system where potential energy does not change with the time, and it is represented with eigenvalue equations for energy operator, right? Energy operator. Now next, let us go for Schrodinger time dependent wave equation. Schrodinger time dependent wave equation explains about time evolution of waves, right? The purpose of this Schrodinger time dependent wave equation is it governs how, or it explains how a quantum wave function changes over the time. How a quantum wave function changes over a time. It explains about this. And here we use partial differential equation. Here we are using eigenvalues. Here partial differentiation. Right? Now next, the formula for the time dependent wave equation, practice well, minus h cut square by 2m del square plus v into psi equal to I h cut dou psi by dou t. Now here minus h cut square by 2m del square plus v we call Hamiltonian operator, and next similarly this I h cut dou psi by dou t we call it as energy operator. If we substitute these both values, h psi equal to E psi. So Hamiltonian operator is equal to the energy operator. So remember the formulas for the Hamiltonian operator. What is that? Minus h cut square by 2m del square plus v. And also remember the formula for the operator, energy operator, I h cut dou by dou t. And so now in these terms we can write it as h psi is equal to E psi. Right? Now next, so do you know what is this operator? Just for a second, I will say about the operator. Operator is nothing but a mathematical tool that acts on the quantum state. It is represented by wave function to produce a new state. Right? It is nothing but a mathematical tool to explain about the wave function and to produce a new wave. Now, these operators represent measured physical quantities like energy, momentum, position, etc. Now, next, let us move towards the commutator. So, here they commutate the two numbers. Now, if, for example, if we take alpha and beta, okay, a commutator of two operators alpha beta I2, then the formula is written as alpha comma beta equal to alpha beta minus beta alpha, or that is equal to minus beta comma alpha. Now next, in this commutator, let us relate a position and momentum. P is the momentum, x is the position. Then how we will write it? If x is the position and p, x is the momentum, then it is written as xpx minus pxx is equal to, in these terms, x comma px, which is equal to I h cut. Right? Now next, if alpha comma beta is equal to 0, then operators are said to be commutate. Okay, commute. Right? If they are having non-zero, now here I h cut, I said no. Now this commutator is having non-zero value. If they have non-zero result, then they do not commutate. Right? Now this particular commutator is a fundamental principle of quantum mechanics known as Heisenberg uncertainty principle. It led to the famous Heisenberg uncertainty principle. Now next, the probability current density. It describes the flow of probability. Describes the flow of probability means, here in quantum mechanics, probability of finding particle in certain region of space can change over the time. So probability current density quantifies this flow, right? Now, here this is written as or indicated with a psi star psi, okay, where psi wave function, psi star complex conjugate, and psi star psi we call position probability density. The formula for probability current density, remember this, practice it, J bar equal to I h cut by 2m psi delta psi star minus psi star delta psi. Now let us go for the expectation values. These are nothing but the average value of physical quantity that would be obtained from large number of measurement. The average value of physical quantity that would be obtained from large number of measurement on systems, where each measurement is performed on the system in same state. Now this is the symbol of expectation value. So expectation value of x, integral psi star x psi d tau by integral psi star psi d tau. The integration of psi star psi d tau is equal to 1. So expectation value of x is written as integral psi star x psi d tau. Right? Now next, in general, let us write the expectation values now following this formula. First, for x f of r I am writing. Now integral psi star in place of x f of r psi d tau. If I want the expectation value of energy operator, in place of this x, no, you just keep I h cut dou by dou t psi d tau. If I want the expectation value of momentum, in place of this x, place momentum operator I h cut dou psi by dou x. Now p square x expectation value integral psi star minus h cut square dou square psi by dou x square d tau. Right? Now next, Ehrenfest theorem. So, Ehrenfest theorem gives the relationship between the classical and quantum mechanics. So, d by dt of expectation value of x is equal to 1 by n m expectation value of momentum px. Similarly, d by dt of expectation value of momentum equal to minus expectation value dou v by dou x. So now one-dimensional wave packets. Under this, some points we are learning. First, the concept of group and phase velocities we are learning. First, a wave packet. Wave packet obtained by superposition of two planes. We write that wave function as psi of x comma t equal to 1 by root pi integral minus alpha to plus alpha a of k e to the power of I kx minus omega t dk. What is k? Propagation vector. Now, what is omega? Angular frequency. So, here see the formula P equal to h cut k, where k equal to P by h cut. Substitute in the place of k. Next, E equal to h cut omega. Omega equal to E by h cut. In place of omega, you substitute E by h cut. Then you will get the a form of this one. Psi x comma t equal to 1 by root 2 pi h cut integral minus infinity to plus infinity a of p e to the power of I by h cut px minus et dp. Now, if t equal to 0, this term will be equal to 1. E to the power of 0, it will be 1. So, the equation becomes 1 by root 2 pi h cut integral minus infinity to plus infinity a of p e to the power of I px by h cut e 0. So, into dp. Now, group velocity. Group velocity means if all the waves in group move in a forward direction, then the velocity of that we call it as a group velocity, the speed of overall wave packets in a simple manner. So the formula is d omega by dk. Now P, you substitute h cut k, and from that you take k, substitute, do dk, differentiate it and substitute. In place of omega, you substitute e by h cut, differentiate, do d omega and substitute, you will get dE by dP. Now next, phase velocity means a single wave packet's velocity, I will say. So Vp equal to omega by k. Now if group contain a number of frequency components in a very small frequency intervals. A group contain a number of frequency components in a very small frequency intervals. Then we write Vg equal to d omega by dk, that is equal to 2 pi d nu by 2 pi d of 1 by lambda. Right? Now next, Vg becomes minus lambda square d nu by d lambda. Remember this formula. Next, relationship between, remember these particular things. Vp, and that is Vp, phase velocity and group velocity. Most important formula, Vg equal to Vp minus lambda dVp by d lambda. Next, Vp, if Vp is function of lambda, then Vg will be less than Vp in dispersive medium. Dispersive medium means where the particle travel with different velocities, and non-dispersive medium means where the speed of wave is constant, does not change with frequency or wavelength. In non-dispersive medium, we write dVp by d lambda equal to 0. So Vg will be equal to Vp in non-dispersive medium. Group velocity is equal to phase velocity. Now relationship between the phase velocity and group velocity. So Vp will be for non-relativistic free particle. Remember that. Vp equal to Vg by 2. So phase velocity equal to 1 by 2 group velocity. We got. Now relationship between the group velocity and particle velocity. Both are same. Vg equal to V. Group velocity is equal to particle velocity. So this is the part 1 of quantum mechanics. More formulas are there which I will explain in part 2. Stay with my channel, right? Receive more videos related to TS set physics. exam, who are attempting the physics exam, please follow my channel, like it, share it, subscribe it. And this matter not only useful for this particular set aspirants, but also UGNet aspirants. And also, I did a video on the notification of radiological physics. Quantum mechanics is one of the topic of the entrance test of radiological physics. Do follow my channel, subscribe my channel. Thank you for watching. Yours Reshma Physics.